Hello. Thank you for joining us today, and welcome to EV charging and multi-user dwellings. I'm Ralph Schweinfurth, Encore Fellow at Forth, and I'll be moderating today's webinar. I'm happy to be here today with a stacked panel to learn and discuss this topic. Forth is a nonprofit trade organization advocating for smart transportation. We work in four focus areas: industry development, demonstration projects, advocacy, consumer engagement. We are advancing smart transportation. Please be sure to submit all questions through the attendee chat, and we will get to them during the Q&A. We'll be sending out the webinar recording after the presentations. Joining us today are Whit Jameson, Program Director of Forth, Ivan Carroll, Director and Developer of Give Development and Board Member of Give Communities, and Jordan Baruti, Sales Director, State and Local Government of Freewire Technologies. First up, we have Whit. Whit, please turn on your webcam and take it away.
All right, good to be here. And close to what Ralph said, I'm program manager here at Forth, overseeing a project on multi-unit dwellings. So without further ado, let's get into it. My name is, hello. There we go. So my name is Whit Jameson, and I've been with Forth for about 3 years, currently overseeing from Forth's role, a 3-year DOE-funded project on multi-unit dwellings and breaking down barriers to accessing EV charging at multi-unit dwellings. And often I'll use multifamily homes in exchange for multi-unit dwellings, but multifamily housing is really what I'm talking about. All right. So I want to start with just a basic. EV adoption is accelerating. You can see it, most in California, but all over the entire United States. We're getting closer to that hockey stick corner. So expect to see a lot more EVs in your neck of the woods, no matter really where you are. And then this slide is just more on the background of networked or smart level 2 chargers, which are kind of the standard for public charging and often the standard for multi-unit dwellings, multi-unit dwelling charging as well. They enable a lot of different features through network connectivity. Obviously, one of the key aspects of a networked or smart level 2 is being able to facilitate monetary transactions. And as I put in that little box, the use cases, public chargers, multi-unit dwellings, workplaces, these chargers are pretty flexible in what they can do. And that's one of the reasons why you see them in so many different places. All vehicles can use the standard AC charging port, and Teslas have an adapter for that as well. Sorry. Something I like to emphasize with really all charging, but one of the biggest values of having an electric vehicle is being able to just plug it in at night. And it takes about 10 seconds to grab the port, open it up, open up your car's port, and plug the charger in. It's really simple and really easy, and providing that amenity to EV drivers in multi-unit dwellings is really valuable to residents. More and more people in multi-unit dwellings are going to be driving electric vehicles over the next 5-10 years. And it's really critical that they have access to this infrastructure in a way that is accessible. And there's also significant benefits to owners, such as in condominiums, where the units can often see pretty sizable jumps in valuation just by having those chargers at their parking spots. As I mentioned earlier, I'm overseeing Forth's role in a 3-year DOE project. And one of the first parts of this project was around identifying the barriers. So we did a survey with experts and kind of took their feedback in. And this was the list of barriers. Obviously, we had to kind of condense a lot of the descriptions here. So in no ways it is an exhaustive list, but does a pretty good job of kind of summarizing different barriers. So some of the high-level technological solutions that are important to know about, and really from a place of, what are some of the solutions? Some of the solutions are shared charging stations and dedicated charging stations, kind of as configuring like what the parking actually looks like, where the charging is, and whether each individual parking spot is going to get their own charging station, or whether you might have one or two chargers for 10, 20 people, and then each person has to move their car to the charger and then move it away after is they're done charging. So there's kind of a lot of different options there, and different charging stations, different charging service providers do different offer different features for how to enable access to charging at multi-unit dwellings. So, and then dedicated charging has simply put, the chargers at the parking spot. Usually this is a higher cost because it's more charging stations, and longer conduit needs to be run. Or rather, the conduit needs to be run a longer distance in order to install the charger. Also, probably a greater amount of panel capacity is needed. And then lastly, offsite charging or other innovative approaches to charging can provide a solution as well. So just more details on shared charging. But as I think in that top sentence, the charger is not owned necessarily by any individual resident, but all residents, and usually also guests are able to access it. The demonstration data showed that usually 10 to 20 kilowatt hours were used per session, with an average session length of 2 to 4 hours. Kind of depends on a lot of factors. And then one last key thing is idle fees. What are they? Basically, when your car is done charging, you might still have the charger plugged into your car. And if the charger has this setting enabled, you might be hit with a fee for basically keeping the charger plugged in after your car is done charging, or after your time session is up. Dedicated charging, I think I went over this a little bit earlier, but power must be run to each space. And one of the keys here that we found is if you have a lot of dedicated chargers, having a load management technology to kind of oversee each charger and kind of manage the load that these chargers bring is important, so that your building doesn't need to necessarily add a larger transformer or increase the power supply to the building. Okay, I'll go through this one pretty quickly, but each multi-unit family or each multi-family home is different, and it's important to recognize that before going into a project. Just a short little snippet on Offsite Solutions. Often DC fast charging hubs can act as a really solid way of basically securing or creating a range confidence for EV drivers, especially new EV drivers that live in MUDs that don't have EV charging. Often they are more expensive, but people often find different chargers that kind of optimize their economic situation, so that they're not going too far, but they're also able to access EV charging nearby. And I should mention there's applications to basically support people finding EV chargers all over the place. So we have a website that was recently published, recently released. CSC led the development of that, and the project team is really excited to get the news of this new website out and about. It's got a lot of awesome resources for residents, property managers, and HOA decision makers. So some of the websites is broken down by this kind of resident, apartment, building management, HOA, different tracks, and they have different steps. I think there's one that has 4 or 5 steps and the rest have 6 steps. there's also this tools and resources section that is really useful for understanding all the details of the project. This is the tools and resources section, and there's going to be a FAQ coming soon. So if you have any questions, there's a place that we're probably going to put them on the website and hopefully add to over the next few months. All right. If you have any questions for me, save them for later. We'll answer them in the Q&A. And you can reach me at whitakerj@fourthmobility.org. All right.
Thanks, Whit.
Back to you.
Again, please submit all questions through the attendee chat. I see some starting to come through. Appreciate that. We'll get to that at the end of the presentations. Next, Ivan, do you want to take it away?
Sure. Thanks everybody for joining. Appreciate you guys taking the time out of your day. I'm going to explain a few things that we did here, specifically in Utah, where we're based. Some of these things may be different from yours. So like Whit was saying, if you have questions that are specific to your situation, go ahead and put them in the chat and I'll see if I can help with any answers. So I work with Give Development and Give Communities. We are an affordable housing developer based in Salt Lake City. Give Development is our for-profit arm, which focuses on mixed income, mixed-use developments along urban cores or other areas that are working to revitalize. Our nonprofit Give Communities, it works on a little bit harder to develop some deeply affordable housing. Mostly does consulting work with other nonprofits or other or housing authorities that maybe need some development support. And we're not a build and flip developer. We build partly to hold the properties long term. So the decisions that we make are with that focus, which may be different than where you're coming from. So just keep that in mind as you listen to what we did. And we also hire a third-party property manager. We are very involved in how our properties run, but we're not there day to day once they're built. With the for-profit and the nonprofit, we've always been driven by multiple bottom lines. Obviously, we need to make money. We also want to make sure that what we build is beneficial for the community. We work to preserve affordability, especially if there's an area that is gentrifying or may be gentrifying soon. We want to make sure that we do what we can to preserve some affordability there. And we focus our efforts on methods that help improve energy efficiency as well, focused on our impact on the environment. And this is what led us to pursue all electric construction and EV charging in our properties. The Salt Lake Valley, a picture I took probably 9 years ago. So looking south, you can see downtown Salt Lake, the Capitol's right there. To the left of the picture, that's the east, and we have the Wasatch Mountains. To the right of the picture, we've got the Oquirrh Mountains over in the west. The majority of people who live in Utah live in these valleys. This is the Salt Lake Valley. Basically everything you can see in this picture is just one big old bowl. And what ends up happening here, if you're not familiar with Utah, is we get things like this, where Utah had the worst air in the world today, according to KRER, our local NPR station, on August 6, 2021. This one's maybe a little unfair to Utah because it was almost entirely from the wildfires that were happening on the West Coast. But what happens is the air moves in from the west, and then a high pressure system sits over the top of us, and it traps everything until that pressure moves out and allows some wind to move things to continue west. So for us, a big reason why we moved to electric construction and are focusing on EVs, electric vehicles, doing charging in our properties, is that impact that most of us that work with Give, some of us born and raised here, some of us moved here when we were young and have lived here for a long, long time. And we would like to breathe the air that we have here and not worry about it. So this is from the Utah DEQ. It talks about the different sources where we get the pollution coming from. And as you can see, the area sources, things that we focused on, things like homes, 29%, and then the electric vehicles would impact that 42%. So we were interested in seeing what we could do. So our first move was to go all electric construction. This is our first project we did. Because as developers, we get to choose how our city's buildings will be built. We get to choose how they're going to impact our communities for decades to come. We obviously need to make sure that fits into pro formas. We need to make sure it fits into city codes. But within those two things, we have a lot of leeway as developers in deciding how we're going to build and how we're going to impact our communities. So Project Open, we basically went all electric to try to just build as close to normal development as possible, but switching everything to all electric. 112 apartments. You can see that building with the mural there in the back. This is the second phase, included a couple of more buildings, including a little brick building you can kind of see in the back of the picture there that was converted into a clubhouse, and some art spaces. Our last iteration of all this, we've gone through a few iterations over the years, is this building here, Citizens West. In each of these properties, we prepped for all electric and EV charging. So that changes a couple of decisions that we have to make. One of them being, this is our house electrical panel. If you're familiar with development, you might notice that for a house panel, this is awfully large. We wouldn't typically have two, super tall panels, plus the third one next to it, plus the fourth one that's over on the other side of the main there. If you look at, this is Project Open, kind of a close-up of its electrical gear. You can see those gray boxes along the concrete there, which is the parking garage. There's 6 sets, so 12 total boxes of electrical gear. There's 3 transformers just across the other side of the parking lot. For comparison, this is 112 units. A previous building that was just standard construction, gas and electric, that was 115 apartments, used 2 sets of electrical gear and 1 transformer. So the conversations with the engineer to get the electric and then to prep this is the slab underneath Project Open. And that little circle, it's really hard to see what's there, but it's a little stub of conduit that we purposely prepped for all electric charging in our parking garage. This is the floor plan for that garage and the front of the building. And there's 45 parking stalls. We prepped, you can see the little orange box shows at the bottom there, shows the symbol on the electrical power plans for the junction box. And if you look about every 3 stalls or so, there's that same symbol. So we were running conduit to all of them in the construction underneath the slab. And we really only prepped those green highlighted stalls to be EV charging. That was our original. That's what we could do in our pro forma. So that's what we were able to do. The city does require 1 in every 25 stalls to be electric. They're looking to move to where multifamily has to have 20% EV ready, or in other words, what we did here, where we put in the electrical panel, we put in the conduits to go under the slab, we were ready to put in chargers. By the time we got to Citizens West, I don't know if you can read this very well, but if you look at every single one of those stalls, it says electric vehicle. We were moving towards, let's just put EV charging everywhere that we absolutely can, as long as we can make it work in our pro formas. And then by the time we were doing EV charging at Citizens West, we found out through Leaders for Clean Air, local nonprofit here in Utah, and UCARE, which is Utah Clean Air, another nonprofit, that Rocky Mountain Power, our local power provider, was providing a bunch of grants. And so we were able to get some grants, and you can see here the total cost is roughly $17,000. The Rocky Mountain Power rebate for the dual port and the single ports, plus the UCARE grant paid for close to about 13 grand of that. We ended up paying about $4,000. These are for level 2. They were Clipper Creek chargers. We had originally done some smart connected chargers, but decided to go just to what they call dumb level 2 chargers. We didn't need the information and we didn't want the long-term operation cost. So that's what we switched to. And just real quick, recapping some of the things that we learned. We're committed to all electric for cleaner air, but honestly, it does save us money in construction costs. And we found that it has benefits for residents not having combustion inside our buildings, and also prepping for the future. It allows us to prep as we move into more electric vehicles. It's a lot easier to change things later if we've prepared the infrastructure today. And those conversations have to start early. If you're looking to do this, you need to start talking to your designers, your engineers, your architects, involve the contractors, involve your financing, the power company, maybe some related nonprofits that can find money in order to provide the cost for these changes. It might be a little different. Again, if you have any questions, let us know in the chat. My contact email is there at the bottom of this slide. But that's all I've got.
Thanks, Ivan. That's fascinating that construction costs are actually less by going all electric. So everyone, continue to please submit questions to the attendee chat. Next up is Jordan. Jordan, can you take it away?
All right, thank you very much. So my name is Jordan Baruti. I am the sales director at Freewire for state and local government. And I've been with the company for about a year and a half. Prior to that, I was with Shell Recharge, formerly Greenlots, and I've been in the EV charging world for about 6-7 years now. I really, appreciate the opportunity to speak with you all. So quick overview on who Freewire is. So we are a DC fast charging and battery storage manufacturer. We're based out of the San Francisco Bay Area. We have headquarters in Oakland, and the company has actually been around for 8 years, working with EV charging and battery storage. We were founded in 2014, and we work with a wide variety of customers, but bring a unique technology to the industry. And I'll go through some of those applications and how it applies to MUDs as well. But kind of backing up and looking at what Freewire is looking to solve for. A lot of the barriers to EV adoption and deploying infrastructure come from limitations with the grid. This is a specific example in California, but basically there are a lot of areas of the grid that cannot accommodate any additional load. And so deploying DC fast charging becomes a challenge. And so we feel and have developed our product around deploying battery storage with DC fast charging so that we're not adding additional strain and peak kW to the grid. This has become, especially clear this week with really bad heat waves in California, seeing rolling blackouts. And so our technology allows us to provide fast charging without kind of the negative effects of that high peak kW. And I'll get into how we do that. But some of the barriers that I think Whit talked about, but just that we see with EV charging in general, not only with MUDs, but level 2 fast charging it takes a lot of time. Where there is not enough power on a site, we typically need to see infrastructure upgrades. These have high costs. And like our previous speaker said, when we can build them in with new construction, those costs are much lower. But much of areas that need to have EV charging, they're older, outdated buildings. There's utility territories that only have 208 volt service, and so bringing in enough power to support DC fast charging is a major challenge and can be very expensive. So our solution to that is actually providing battery storage integrated into DC fast charging. So we take a battery pack, we combine it with all of the internal components of a DC fast charger. We vertically integrate it all into one housing. You can see it on the screen. We source our batteries from Tennessee, the same supplier for Nissan. And we've been working with batteries and charging for over 8 years and have deployed megawatts of power across the United States. And there's some additional benefits to doing that, and I'll get into that as well. But in terms of how it works, and one of our unique attributes is that we can actually connect DC fast charging, so our Boost DC fast charger, to low voltage grid service. So the same voltage, the same grid service you would need for level 2 charging, 240 or 208 volt, and we'll pull no more than 27 kW from the grid. So about the same amount of power as 3 or 4 level 2 will charge our battery. From our battery, we can then provide up to 200 kW output to a vehicle, so giving 100-mile range to a light-duty vehicle in 10 to 20 minutes. So in terms of space, battery integrated technology allows us to install with much less footprint. You can see kind of on the right-hand side, the very specific dispensers, power cabinets, switchgear, transformers that are needed for just a couple of high-powered DC fast chargers. So our technology basically allows us to take all of that and put it into one small housing with a Boost. And with that, there's some unique benefits that we can provide to an MUD or nearby an MUD, and I'll get into that. Lastly, I'll mention on energy costs and operational costs. Because we have a built-in battery, we can provide built-in peak load management, basically load management that comes with the unit. Since we pull a peak of no more than 27 kW every time a vehicle plugs in, we're not going to see 150 kW peak from the grid, and those demand charges are managed to a much lower amount, saving thousands of dollars per year. And when you look at 5-10 years of operation, we see a huge reduction in total cost of ownership for DC fast charging. So in terms of multi-unit and multifamily as well, I know that term is more preferred. So for multifamily applications, we were part of that VCI-MUD study or multifamily study that WIT went through. And we basically had an older product called the Mobi that had battery storage integrated into a level 2. And so we worked with an apartment complex in San Mateo who had 5 EVs. And some of the benefits of using that battery technology is that we were able to deploy charging without doing any permanent install at the property. And then we were able to charge that Mobi from a wall outlet, essentially off peak, and then provide charging on peak to those vehicles. But some of those project challenges included needing an attendant for our mobile charger. So it, not in terms of the actual technology, but needing to move it around became a challenge. And then there's a high CapEx aspect of deploying that piece of equipment. So we don't make that product anymore. We've discontinued it, but we've been able to take some of the learnings from this MUD study or multifamily study and basically apply it to some applications for the Boost charger, which also has battery storage. So the first being community-based DC fast charging. So that's essentially, as Whit mentioned, placing DC fast charging in the public sphere, but nearby multifamily dwellings. So in this example, Freewire has been awarded multiple different funding opportunities in California, one of which is with the city of San Diego. And so we're able to install our Boost charger at a city park and basically locate that near a multifamily dwelling where they have access to that location. And these grant programs have a focus on disadvantaged and low-income communities. And because of the low infrastructure requirement for the Boost, we're able to easily install and actually take advantage of lower cost of energy. And we're looking to provide that lower cost of energy then to the driver because of that built-in battery capability. Additionally, for on-site and communal applications, we worked with a company in Santa Barbara. We won a grant award with the Air District there that has basically allowed us to install a Boost charger at the retail center of their property, which they also own a multifamily housing complex as a part of that connected shared property. And so we're able to give access to those residents to a fast charger, but also serve the retail center. And so I think there's a unique case here in which we're able to do multiple different types of charging and serve multiple different types of EV drivers, and then still give access to those residents that live nearby. And then with that same group, we're also looking at a communal DC fast charging approach, where we essentially can install our Boost fast charger in the visitor area of a multifamily complex. And while typically, and as Whit mentioned as well, I think the main application for MUDs and multifamily will be level 2 and even level 1 charging. There are some complexes where either they don't have parking available, or there is parking that's spread out across an outdoor area that makes it hard to bring conduit to every single stall. And so there is an application to allow for one DC fast charger that's shared amongst the residents. And with that, we can actually get more throughput of vehicles using 1 or 2 stalls than you would get with a level 2 charger. So for example, in the Santa Barbara example, we have 2 level 2 that are already installed, and they're basically serving 15 to 20 EVs on site. And so with that, they can only get maybe 3 to 4, maybe 6 cars a day charged. But we can actually take that same grid infrastructure from those level 2. We've done this with other projects where we essentially swap out the old level 2. We can place our Boost over the top. We pull new wire, and they basically get a high-powered DC fast charger without adding any additional significant grid or utility load. And then we can charge 15 to 20 cars a day, each with about 15 to 20 minute charging sessions. So some unique applications that we're starting to explore in the multifamily space. And it's really the Boost technology and the battery integrated technology that allows us to do that. So as a summary, we can provide lower install costs than what you would typically see with DC fast charging, and a lower cost of energy because we're pulling that lower peak from the grid. We can charge 15, 20 vehicles a day, only taking up 1 to 2 parking spots. And we have that built-in load management, which reduces the cost of energy for the charger owner. And it gives opportunity to lower fees to drivers compared to kind of your standard public fast charging fees. And then to help with the upfront cost of deploying our charger, there are many grants and incentives, but we can also help with the financing of that charger so that it's not an upfront cost to the property owner. They can actually spread that out over the course of 5 or 10 years of operating the charger. And then we have network options as well that allows them to essentially collect revenue from drivers to help recoup the cost of that product. So really appreciate your time. Look forward to answering any questions. Thank you.
Thanks, Jordan. Okay, everyone, it's time to start the Q&A. Let's everyone turn their webcams on, and it looks like we have a good set of questions, so we'll get started with this. I guess to kick it off, just to get, I guess, everyone's opinion, I'd like to understand what's one piece of advice for property managers, HOAs, or residents that you would recommend as we're going through this charging in multi-unit dwellings or multifamily housing. Whit, do you want to?
I can start. Sure. I'll go from a high level, but understanding the demand, and from the decision maker kind of point of view, understanding the demand and also understanding the future demand really is valuable. And that that can be the difference between thinking you're going to be fine with 2 shared EV chargers, and in reality you might actually want to go with a DC fast charger in the long term, especially if you're at a mixed use location.
Okay. Ivan?
One thing I think is paying attention to the people that are there and the people that will be coming there. So if you're talking about HOA, property manager, it's finding ways to listen to the people who are there and then their needs that are coming up. So For example, it may be that you have a lot of people who would love to have an EV, but maybe an HOA doesn't allow you to install a charger at your home, or maybe you've got a multifamily property that has the difficulty of retrofitting, but there are methods to retrofit. But if you know that it's a need, then that helps push your decision making. Whereas if you're not going out and finding out what the needs are of the residents or the people who live there, then it's difficult to know what to work on.
It makes sense. Jordan, any advice you would have?
Yeah, I think both Whit and Ivan had great advice. I would also add on to that, looking for grants, incentives. There's a lot available to take advantage of to help lower the cost of installing and kind of planning for the future for what's going to be needed, not just now, but 5-10 years down the line as more and more EVs are on the road.
Yeah, those are some good points. Okay, for the next question, I'd like to ask, what do these various options cost the end user, and what can be done to ensure equitable pricing for car charging between multifamily housing and single-family housing?
I can try to start with an answer there. So usually public charging is going to cost more. Often multifamily home charging is going to cost more as well. I think Ivan's example of kind of balancing out between a networked smart charger and a non-networked dumb charger is a good example of if the charger is going to basically be dedicated to that parking spot. It might make more sense to go with a dumb charger because you're not going to be worrying about how much electricity that person's pulling, and you're not going to be worried about which resident is using those chargers. Additionally, if you run the conduit ahead of time, you can theoretically route it through a meter and have that parking spot be metered to a specific unit, though that can be tricky. I'm sure, Ivan, you can delve more into that. But the actual difficulty of getting equitable pricing between multifamily homes and single family homes is a lot more complex than that. And I think goes to partially how utilities see the rate structures for these sorts of loads, and how even the utility commissions, the utility boards at the state level view this as well, because residential prices, especially single family home residential prices, are a significant benefit to people, right, to EV drivers right now, and multifamily home doesn't exactly have the same luxury of those rates. Often the rates include demand charges, and yeah. Okay. I'll pass this off to Ivan or Jordan, if either of you two have thoughts.
I know there's some, excuse me, some questions about cost, and it's hard to know exactly what it's going to cost the end user because that depends a lot on how you're operating it. So for example, you could charge a flat fee and say, all right, you get this parking stall, and that flat fee helps cover these costs, and charge whatever you want. Or you could sub-meter it. I did see a question come through. No, we're not. We can't connect every single parking stall to its own separate meter tied to the utility. We have a house meter that has all those parking stalls. And then you could sub-meter and charge the person there, or you could use a network connected charger that the person has to use an app to open. There are even some not fully network connected, but that still allow you to access via an app, so you can kind of control. And then it's really up to the owner of the building or the property manager, or however you're operating it, to decide, are you just charging the fee for the cost of the electricity? Or are you charging more to recoup some other costs? So it's hard to answer that question without knowing the individual case, but that's generally how we've seen it done.
And I would just add, it's typically up to the charger owner to set pricing. But one thing that from a technology perspective that we can provide is because we're pulling that lower peak kW than a traditional fast charger, typically we're going to see lower energy costs for the charger owner. And so what that allows them to do is still make a return while offering lower fees to the driver in that public scenario, but also potentially at an MUD facility for that multifamily driver group.
Okay, thank you. For the next question, someone was curious to know if the GIVE projects include signage for the EV-capable, EV-ready spaces. We were struggling with the lack of signage design guidelines for EV-capable spaces.
Sure.
Ivan?
Yeah, the only signage that we installed originally was for the few stalls that we had put EV chargers on, and just put electric vehicle charging on the stall itself. Since our later projects, we just did every single stall in the garage as with an electric vehicle charger. We didn't put up any signage. So no, we haven't put any signage that shows it's EV capable or EV ready or anything like that.
Okay, for the next question, with shared charging, how is vehicle charging tracked?
Usually through an app or something that connects to a specific account, and then the backend software can kind of bill that way or track. Justin, would you add, or Jordan, sorry, would you add anything?
Yeah, I would say, with network charging, you can track users and set driver groups. Basically, you have the capability to see, what usage has happened at each port and down to the port level, so that you can understand, what's happening there. And then you can charge, if you're collecting revenue for those sessions, you can charge by that individual user's session.
Okay. Thank you. All right, for the next question. Ivan, is each parking spot then metered individually? Okay, I think we kind of talked about this briefly. And I think the answer is for the later buildings, the everything is kind of done together as far as the metering goes. So it's not an individual meter on the newer buildings. So I think we covered that one. Next, any grants available for existing condo HOAs who don't have adequate electrical infrastructure for older buildings?
Jordan, you want to take this one, or?
Yeah, so I mean, a lot of the funding that's out there that I've seen, specifically in California, whether it's the Energy Commission or Air District grants, does have a kind of an additional weighting towards serving multifamily housing. And so there are grants out there that can be found, whether it's state energy offices. I would also say, I think it's Atlas Public Policy has a great kind of set of what incentives and grants are available out there. But you can also go to the DOE AFDC website and find incentives and grants there. But yeah, I would say I've seen a trend moving towards grants and incentives having a weighting towards charging that will end up serving multifamily drivers.
And I would add, I mean, the way that we found our grants was through local nonprofits. Clean air is a big deal in Utah. So if you live in an area that has nonprofits working on clean air, maybe just research that. And a lot of the funding actually has come from Rocky Mountain Power, which is our subsidiary of Pacific Corp here in Utah. And so I would reach out to see if the local electrical company has funding available, see if there are any nonprofits in your area that are connected specifically to electrification or EVs just generally, and they might be able to point you in the direction of people nearby, because we didn't even know those existed until we found Leaders for Clean Air, and they turned us on to those grants.
It's also
Okay.
important to recognize a lot of utilities are going through a change and transition right now, and understanding that multifamily homes and multifamily housing is becoming a hot button item for EV charging. And as they kind of spin up programs for EV charging in general, they're more likely to have specific grants and rebates for multifamily housing EV charging.
Okay. I also know Zappy Rides is another place, another website that sometimes has some of the offers for rebates. Okay, thank you. Next question. What is the battery capacity in kilowatt hours per unit?
So for the Boost DC fast charger, we have a battery capacity of 160 kilowatt hours.
Okay, great. Let's see. Thank you, Jordan. For the next question, from your perspectives, what role could local professionals, urban planners, engineers, and others working in land use, etc., play to escalate the effective deployment of multifamily charging stations at the local level?
I can.
So,
You go, Ivan. You go, Ivan.
so I was just going to say, I mean, planners, city planners, you wield a whole lot of power. If the decisions that you make obviously have to live within an entire ecosystem that involves not pushing developers out or business out, but at the same time, cities wield a whole lot of power in guiding the direction that you want to move. And I know that maybe one planner at one city isn't going to have a lot of sway, but I think if you are that one planner that wants to work on electrification, cleaner air, cleaner energy, keep the conversation going. Like, just be the person who brings it up in the meetings, be the person who reaches out to other places that are doing the things that you want to see done, and bring them to the office. And then with engineers, architects, things like that, when we toured people through Project Open and we talked about how we had switched to all electric, I had a couple of different architects and designers tell us that they had tried to convince other developers to do it, but they weren't willing to because they didn't want to be the guinea pigs. Where we jumped in and were the guinea pig, and we showed that it could be done and it was cost effective and it worked. So be the person starting the conversations with the decision makers, the developers who are making those decisions, with the city officials that you work with, and try to find places where it's working. Try to find examples you can point to, because developers fear being the first one doing anything. So you need to find somebody who's done it and figure out whether it worked or it didn't work. If it didn't work, how could you make it work?
Can I add? There's also sometimes ordinances like minimum parking requirements that don't really have a way around EV charging spots. So when you swap a parking spot for a charging spot, basically you might fall into areas of missing that minimum parking requirements. And some places get around that through basically saying a charging spot is a parking spot, or removing the minimum parking requirements entirely, or a couple other methods as well. But there can be a couple pesky ordinances and requirements that need to be worked through. There's no better people to work through it than the urban planners at cities.
Okay, thank you. The next question is how does Freewire ensure reliability of their charging stations? Jordan?
Yeah, great question. So we always deploy our chargers with a full service warranty, so parts, labor, repairs, preventative maintenance, and then the station itself is connected through cellular, so we have access to the data of what's happening with the health of the unit, and we basically get notified if there's anything going wrong with it. We can deploy our service technicians to the site and repair whatever's going on. But yeah, that connectivity allows us to see real time what's happening with the charger and respond quickly to make sure that there is reliable charging and that sessions can happen.
So Jordan, kind of a follow-up question for that might be, what's your kind of mean time to repair when you spot something?
Yeah, I mean, it really depends on what the issue is, but we typically, look for a 24-hour turnaround if possible. Again, a lot of times it ends up being either user error or connectivity issue, in which if we reset the station, it's ready to go from there. But yeah, it's really nuanced in terms of what the actual issue is to repair for that answer.
Okay, sounds like the response is really fast. So that'd be really helpful. Kind of a follow-up question to, I think, your presentation was, what was the DC fast charging output again in kilowatts per connection?
Yeah, so we can provide up to 200 kW output from one connector, or we can use both connectors on the boost at once and provide 100 kW for each connector. And then we can do CCS and CHAdeMO, or we can make both connectors CCS if desired.
Great, thank you.
Mhm.
Next question. It'll be great to be able to check the box on Craigslist that I can charge an EV. However, how can I track usage amongst multiple users so I can charge them before they have their entire senior class use my charger?
I can start with that. Jordan, you can finish it. Not sure if I get every aspect of that question, but simply put, you can have access controls. So theoretically, you could even, give out a bunch of RFID cards, so little like scan cards that controls. You have to have one of those cards, cards to be able to access the charger, or only certain account numbers that have been registered in the back end can access that charger as well. Or I've even heard of other systems with non-networked chargers, such as PIN codes or even a key system. But those are kind of not as sophisticated as the account method.
Yeah, and I'll just add to that, with Boost specifically, we have a touch screen with credit card readers. We can connect to those network apps that allow for access control. So basically, there'd be no way to use the charger without authenticating first and paying for the session.
Okay. All right. So, let's see for the next question. Jordan, it seems like the Freewire unit, when its battery is fully charged, could charge only a handful of cars, maybe 4 or 5, depending upon battery size, level, exhaustion. Then Freewire battery be exhausted. How does the unit then effectively serve the vehicles that come afterwards? Does it effectively become a level 2 charger? Does the Freewire unit have a way of alerting users? However, it doesn't happen. I think it also kind of talks to perhaps kind of utilization you can get out of one of these systems. Jordan?
Yeah, absolutely. So the battery pack is 160 kilowatt hours, but we're also able to pull about 22 kilowatts from the grid to support a charging session. And if we look at kind of the standard DC fast charging session, it's anywhere between 25 and 30 kilowatt hours per session. So we can certainly handle more than 4 or 5 vehicles in a single day. It will depend on the session length, the battery size of the vehicle, but if somebody's going from 20 or 30% to 80% state of charge, that's really the use case for a DC fast charger. And so we can handle 15 up to 20 sessions a day in that range. And what happens is that in between sessions, we're able to recover our battery. So the battery starts to recharge from the grid whenever somebody's not charging. And then when somebody plugs in, we then can discharge from the battery. If we were to get into a scenario where we had constant utilization, depletes the battery pack, we still have that about 22 kilowatts from the grid that we can provide that vehicle. So it's still 3 times faster than a 7 kilowatt level 2. So a car will not be stranded. They'll still be able to charge unless the grid goes down. But that would be a different scenario. We actually have a capability if we do have full charge in our battery and the grid goes down, we can still offer a charge session from that battery. So I think it's also important to note There is some limitation on the number of sessions we can do, but there's also a benefit of the resiliency aspect of having stored energy on site, which you can use if the grid does go down.
Okay. Thanks, Jordan. Okay, so I think for last question, how do you foresee integrating EV charging in MUDs with residential managed charge of programs administered by utilities?
That's a very specific question, but I love it. And I'll try to loop in both Ivan and Jordan on this one too. It can be tricky because when you have a residential managed program, managed by the utility, there's always the chance, like what you're seeing right now in California, of companies kind of overriding the existing protocols and basically saying, hey, we can't charge right now. And that in and of itself is going to evolve, I think, as we get more experience with these programs. But I do see more and more utilities wanting to go that way and to have a greater control over their load, which I do think is a good thing. But it's also going to require some amount of flexibility from the demand side, people trying to live their lives. And that in and of itself is kind of the end goal. We want them to be able to do what they want to do and charge their cars when they need to. I hope that is, yeah. Jordan, do you?
Yeah. From Freewire's perspective, I think because we have the battery buffer, we're already providing a lower demand from the utility than what we're outputting to the driver. So if a utility wants us to lower our input from the grid, we can do so without interrupting a session, and we feel that's better for the driver's experience. Instead of vehicle to grid or demand response where we're lowering the output to a vehicle, we can actually keep that driver experience going while we use the battery to manage what the utility needs on the back end.
Okay.
I would add, I don't know that anybody foresees electric vehicles going away. So we're going to have to find a solution. Battery storage is becoming better. What Jordan has been talking about is a good option for allowing a little bit of a shift as we deal with a lot of the electric grid problems that probably not going to get easier either, not going to go away either. So it is a good question. I'm not sure that anybody really has a great solution today, just working towards improving the grid, improving our power at our properties as well.
Okay, I think we're at time right now, so I appreciate everyone's questions, and I appreciate everyone's participation in this webinar. Thank you for joining us today, and a big thank you to Whit, Ivan, and Jordan for helping us understand this topic. Feel free to email any additional questions to us, and we'll send out the presentation slides and additional resources after the webinar. Thank you again, and hope you can join us for another webinar in the future.
Thank you very much.
Thank you.
Thanks, everyone.